Okay, let's take a look at 802. Find eventual self-states. So we're given a directed graph. We start at some node, and every turn we walk along a direct edge of the graph. So if we reach a node that is terminal, we stop. So what does this mean? Let's take a look at this example here. So we have our input here, right? That means that the index 0 is our graph node 0, right? So from 0, I have two edges. One from 0 to 1, and another one is from 0 to 2, right? Okay, for our node 1, we have edges. We can start from walk from 1 to 2, and we also can walk from 1 to 3. Okay, so here we can take a look at this part. So we can start from 0 and then to 1, and then we can go to 3, and then for our 3, 0, 1, 2, 3, we see that from 3 we also can return back to 0, right? So here is a circle, which is from 0, 1, 3. So these three nodes are not safe state, so we're not going to return them. So let's take a look at it 2. So we can start from 0 to 1, and from 1 to 2. And we see from 2 we cannot go back to 1, neither to 0. So 2 is a safe state. And we can start from 2 to 5, right? Because we have the edge at here, from 2 to 5. And 5 cannot go back to 2. So 5 is a safe node. And also 6, there's no edges that can to any of the nodes, right? So 6 is another safe node. Yeah, so after we review this example, so we get to know the core of this problem is ask us to find if there's a circle when we traverse these nodes. Okay, so here this is a graph traverse problem, right? So we can use algorithms such as DFS or BFS, right? So because we're going to check if we have a circle, I think I'm going to use DFS to check if there is a circle, right? If there is a circle, the node, if circle is true, right? It means we do have a circle, so the node is not a safe node. Safe node, okay. Yeah, so yeah, we're going to use DFS to traverse each of the nodes and to find if we can reach to the terminal without going back and back again. So if there's no circle, we just add the node to the result as a safe node. Okay, so the time complexity is going to be big O of m, because we're going to traverse every node and in our input, right? And our space is also going to be OM. Okay, right. Let's start coding. First, we need to initiate a data structure to store our results, right? So we can do a base case check. If the graph, our input, equals none, or the graph's length equals 0, we just return our list to nothing, right? Okay, so we're going to check if there's a circle, right? I'm going to use a data structure to help me to find if there's a circle or not. The data structure that I'm going to use is hash set. So I'm going to use two hash sets. The one is called visiting, means that I'm on the path that visiting, on the visiting path, for example here. So I'm going to add 0 into the visiting path. So 0 added to visiting added 0, and then we add 1, then we add 3. So when I go back to see, oh, the visiting already has 0 in the hash set, right? Then we say, oh, we find a circle. Cool. So here, I'm going to use another hash set to record the node that I already visited, that I already traversed. So next time I do not need to traverse it again, right? Okay. Hash set. Okay, so we're going to iterate our input and do the DFS to check if there's a circle or not. So let's for loop our input. I smaller than graph down length. Okay, I plus plus. So each I means the node that we have in our input, right? So if we do not have a circle, right? It means we find a self node. We just use the list to add it. Okay, so we can put our I in there and graph in there, visiting, visited. Okay, finally we're going to return our result. Cool. So let's write this boolean has circle part. Let's say the index our graph and set visiting, and we have another set visited. Okay, so let's do the base case check. First, if our visiting contains the node, right, we return true. It means that we do find a circle. So if our visited contains the node, we return false. Okay, so we're going to check the neighbor of node, for example, of the node 0. Okay, so into neighbor as graph index. So we're also going to, okay, before we do this for loop, what should we do? Our visiting should add index, right? And then we do the for loop to check the neighbor and see if a circle neighbor graph and visiting and visited. If we do have a circle, we'll return true, right? Otherwise, return false. Okay, so here we need to remove the node from the path that we're traversing right now, right? Okay, we're going to remove index, and also don't forget to add the index into the visited. Okay, I think I will finish our coding. Okay, let's check our code if we have any typo here. So, okay, let me select comma. Visiting, okay, here's contains, right? Okay, let's run the code. Cool, accepted. Nice. Thank you for watching.